Previously, we figured it out what was actually happening behind projectile motion and came up with a formula. However, there is one problem. The formula will be no longer accurate if the target locates at different height from Ganyu.
Adeptus shall!
But don't worry, my dear fellow countrymen. With the clues in the last video, we should be able to further improve our ballistic formula. Suppose that there is an object traveling with velocity v. However, the velocity changes with respect to time. And in this case, the object is getting faster. We call v0 as initial velocity, and v1 as the object's velocity after 1 second. The difference between v1 and v0 is acceleration, or the rate of change of velocity during 1 second. But what happens if the velocity get the same acceleration every second? That means the object's velocity is changing at constant rate. And in other words, the object's motion is uniformly accelerated. So if we wish to calculate the rate of change in velocity during a specific duration, we have to multiply the acceleration by time. And my dear fellow countrymen, this is the formula that we used in Kaya's example. And we gonna use it again. All right. We all know that if an object travels with constant velocity, then the displacement will equal to that velocity multiplied by time. Now I know this is weird, but imagine we have a rectangle with the two adjacent edges length our velocity and time respectively. Guess what? The rectangle's area is equal to displacement. Applying this to uniformly accelerated motion, the displacement will equal to the area of this trapezoid. From what we've found out, we should be able to construct the equation of uniformly accelerated motion. If you wonder why we have to go through all of these, then try to remember what happened to Kaya's Mora. Exactly, my friends. The vertical motion of projectile motion is uniformly accelerated motion. The next step is pretty easy. I guess we won't encounter any difficulties this time. Suppose that the origin is our Ganyu, and the target locates at a known coordinate. If the amount of time for the arrow to complete its trajectory is t, then we can construct an equation of the vertical motion with Vy as initial vertical velocity. Additionally, as the horizontal velocity remains constant, it will be equal to range divided by time. I hope that you still remember the constant x in the last video, because if we combine this to the two formulas and apply some trigonometric magics, we can construct a new equation, which is a quadratic equation with two roots, because there are two possible angles of reach for a fixed initial velocity to reach a specific target. Since we've already figured out the value of x, this is how the final result is supposed to be.
Yeah, baby!
However, there is one problem. How to measure the height and convert it to Tavit unit?
Good question, comrade. At this moment, I am trying to figure it out, and the answer shall be available in the next video. For now, my dear fellow countrymen, it's time to say goodbye. We shall meet each other in the near future.